Okay, hello everyone. If anybody is already here, let me know how the sound is. Oh, I can hear myself. That's not good. One second. Okay, there we go. Hopefully that didn't feedback or anything crazy. But yeah, if anybody is here, let me know how the sound is. We'll get going in just a minute. Just getting the last few things set up here. Oh, I see. It's because I had Twitch open. Okay. Alright, I think maybe I can put that down. Put this back up a little bit. Okay. And let me make sure my chat is somewhere where it's not going to get locked up, hopefully. There it is. Okay, I think it's good. Alright, let's go ahead and get started. Quick introduction. My name is Tim. I go by foamyguy online on Discord and GitHub and all the usual places. I have been working on CircuitPython for a little over a year, about a year and a quarter or so at this point. Since about the end of 2019 is when I really first started contributing. Sound is a tad low. Let me bump it up some. Thank you. And good morning, Jose. Let's go here. Let me know how that is. I think I have another place I can still turn it up a little more if we need to. But let me know how that is. So yeah, my name is Tim. I go by foamyguy most places online. Been contributing for a little while now, and been streaming for about a month or so, and having a lot of fun with it. In this stream, we're going to be talking about CircuitPython. If you don't know anything about that, CircuitPython is a version of Python that runs on tiny computers called microcontrollers. And it's made to be super easy, especially for beginners, to get started with programming and electronics. So it's really nice for folks who don't have very much experience at all, but it's also really nice for folks like me who have been in software development for a long time and do have a lot of experience. The nice thing that CircuitPython offers us is a really, really quick ability to iterate. So you can try out an idea really fast and see if it's going to work or not, and kind of change it up on the fly real quick and easy. So that's what drew me to CircuitPython. And I kind of, it became something I'm pretty passionate about contributing to, because I think it's a really neat project and a really great way for folks to learn how to program. Even though I didn't use it to learn to program, I think it's a really amazing tool for that. So that's why I've gotten involved. In this video, we're going to be looking at a little bit of library development and maybe some other stuff outside the libraries, just in some projects that we've been working on lately. Sounds good now. Thank you, Jose. So yeah, let's dive in. I guess in the introduction still, before we get going, CircuitPython, it's an open source project. So you can see my screen here. I'm going to pull up the website for it. CircuitPython.org is right here. All the information and downloads and everything that you need in order to use CircuitPython is on this website right here, CircuitPython.org. And the financial backing for CircuitPython, it's an open source project, but the financial backing comes primarily from a company called Adafruit. So adafruit.com is right here. They are a hardware and software company based out of New York in the United States. You can buy from their website, adafruit.com. You can buy all kinds of electronics like the microcontrollers we're going to be working with, and all kinds of things that you can hook up to them, like sensors and LEDs and breakouts of all kinds and buttons and anything you can imagine, really. So if you like CircuitPython, if you like the kinds of stuff that I am working on, and you want to help support the project, the way that you can do that is by purchasing hardware from adafruit.com. So please do that if you can. They're not paying me for this video. They don't pay me to stream this stuff. I do this just for fun, but they do pay me to work on guides and other software from time to time. So I do work for them, but not for this streaming endeavor here. Okay. I think that's it for the introduction. Let me catch up, see if anything else is here in the chat. Good morning to Jose, and let me make sure I don't freeze the chat. Okay, so we're going to go ahead and dive in a little bit. The thing I want to work on first today is going to be some testing of this core. Whoops, accidentally got a different browser there. This core PR right here. So this is in the CircuitPython core. You can scroll up right here. It's PR number 4432. So Jeff Epler has been working with Kmatch lately, Kmatch 98, to put in some enhancements to bitmaps. And in this case, it was it kind of stemmed out of the first enhancement, which was, I think, bitmap.readInto. And from the testing on bitmap.readInto, Kmatch noticed some different things, like, hey, what would happen if you did this, or what would happen if this thing happened? And so Jeff kind of went through the code and tried to harden it, I guess, if you will, to make it, more resistant to misuse. So this is the code inside the core. This is the core of display.io. So if you have watched the stream before, one thing you'll know is that I do focus a lot on display.io. And so, again, today we're going to be working on that. So Jeff made a bunch of improvements inside here, and we're going to do some testing. I did play with it a little bit last night, found a little issue. Kmatch dug into it a little bit further and figured out what the problem was and figured out a fix for it. And so there has been a new commit with that fix, and so we're going to test that out. And then it looks like there's actually some new stuff since the last time I looked. So Kmatch also found some other things, maybe off by one error in the rotozoom, and Kmatch left this really nice test code here. So this is what I'm going to run here in a second. But it looks like there's new activity here. This is great. Add your tests in tests CircuitPython manual. Huh? I didn't know there was a. That's terrible, right? It's probably pretty bad that I didn't know this, but I didn't know there was a test folder. Let me see what else is in there. I'm curious about that now. CircuitPython, repo, tests, CircuitPython manual. Socket pool audio. Looks like mostly audio stuff plus bus.io and socket pool. Yeah, there's a pretty good opportunity here for some more display.io tests inside this folder. How's it going, Dexter? Thanks for joining us. Johnny, how are you this morning? Hugo, good morning. Hello. 4 p.m. here already. In that case, Johnny, I think I said good morning to you. In that case, it'll be a good afternoon, though. Good evening, almost. Thanks for joining us, no matter what time it is. Off by one error is two of a kind. Yep. Only because I'm 6 time zones ahead. Yeah, time zones. Time zones are a lot of fun. And daylight savings time. I've been working with that in my day job a lot lately. I'm building a scheduling system. It's been a nightmare to deal with different time zones, and then daylight savings time happened right in the middle of it. Anyway, that's totally off topic. Okay, so this is actually cool. I never knew these tests were here. This might be something maybe we could contribute to one day, is write some more of these tests, because these are just Python code, I think, probably, right? Or, well, these are audio files. This is the one I was in, wasn't it? Yeah. MP3. What about audio bus? Yeah, these are Python files. So yeah, maybe one day we'll whip up some more display.io tests and make a PR with them. Johnny's in the future. Nice. Did my homework yesterday. Oh, let me switch over to Discord real quick. I think I'm behind the scroll, kind of. I see the translation peeps have been slacking off. Swedish is the only one at 100%. Got Swedish full. Dealing with remote team who's 12 hours ahead. I remember to force myself to say good evening to them as they say good morning to me. Nice. Yeah, I'm relatively lucky. Some of the folks, like other companies that we work with, are in some different time zones. But all the folks that I deal with on a regular basis are all pretty close to me, within like 2 or 3 time zones. All right, we got Arnie going there. Nice. Oh, I changed up the camera a little bit too. I got a new camera this week, so we'll see how this goes. It's kind of wide angled. I don't know. I don't know if it's what we'll end up with, but it is new this week. We're in a different place, so it does look a little bit different. If you notice that, that's why. All right, let's grab this test code, and we need to build maybe CircuitPython because Jepler pulled in the first one of these fixes, which was greater than less than. I think though maybe Jeff has not had a chance to pull in the other one yet, so yeah. I think we need to grab kmatch's branch and then build from there. So first thing I'm going to do though real quick is just grab this example test code, and I'm just going to do this on the thing I have loaded up here. I don't know if I showed the camera yet. This is the RP2040 feather. So feather RP2040. I don't know where the name is at on there. I guess it's by the chip there. RP2040 feather, and then you can kind of see in the light there, this is a 3.5-inch feather wing. So if you watched JP's workshop and show and tell and some of the other stuff this week, then you've seen this project here. It's the touch deck, and so the main one runs on this feather RP2040, but we're going to be working on PyPortal, I think, as well. I know I started development on the PyPortal, so if you watched last week, you saw some of that, and so yeah, we're gonna have a PyPortal version, but I am working on the RP2040 feather for right now. I figured that's good to go ahead and test out this stuff on the brand newest device, because maybe we find potential issues with that device still. So good to do some extra testing there. So let me just save this code on here. I think what I'll do is save off this version of the touch deck code real quick. Touch deck code. I already got one, so I'm going to replace it, and then we can just load up code and then paste over it. So here's that. I need to still set up my layers for this thing. I've just started building out my custom layers for the touch deck, and I'm already really excited about all of the different shortcuts. I have a list of ones I want. I just need to put them into the layers now and make some icons with it. It's really nice, those blank colored icons that JP made for us, so that's gonna make it a lot easier for me because I'm not great with photo manipulation. I can kind of know my way around GIMP a little bit, and I can kind of get some stuff done, but I'm not very quick or good at it. So those colored icons that JP provided are going to be awesome for me. I can just paste stuff right into the center of those, go on my way, get my stuff loaded up in those layers. All right, let me catch up on the chat real quick. Speaking of the chat, I don't think I mentioned today, I mean, of course, most of you folks know the chat. You can see it down at the bottom of the stream there, adafruit.it/discord. This is the Adafruit Discord channel. We're in the live broadcast room. You can come and hang out with us there if you want. And I'll try to keep an eye on the Twitch chat as well, but I freely admit I'm not as good at that, so if you do drop something in the Twitch chat, be patient with me, or maybe try to ping me. I don't know if you can ping on Twitch or not, but if so, that's totally fine if you want to. Alrighty, got some good mornings. I think we're talking about translation updates here. Yep, converting foamyguy stream into our own weekly Weblate meeting. Yeah. No, you guys are fine to talk about anything, really. Weblate, I don't speak any languages besides English. I've been trying to learn Spanish a little bit, actually, by using the Spanish builds of CircuitPython. I've gotten a little okay at recognizing some of the errors and stuff, but I have a long ways to go. It's nice that I know a lot of what the stuff says in English, and I can kind of relate them back and forth like that. But anyway, you guys are totally cool. If you want to talk about Weblate or anything in the chat, that's no problem. Where are we at here? Did I save this? I did, yes. So we need to build CircuitPython. I don't have PyCharm open, so let me get that. And while that is loading, let me see where we need to go, which is kmatch bitmap 30 improvements. So we're going to check out this branch. Looks like it didn't pass actions yet. I don't know if that's just because it is in kmatch's fork or what. I don't really know how all the actions in the core work, honestly. Also, this says all checks have passed. Huh. Why is it a red X then? I don't know. Anyway, let's go here. Let's get CircuitPython open. Do I want my clone? I think I want adafruit's clone, probably. I have a couple of different cloned copies of CircuitPython because I find it easier to work that way. I have adafruit separate, that way I like never push to it accidentally. I think that's what I want because I won't be pushing right now. So let's go open this. Let's go a new window. We're going to use display layout later. Okay. So first thing is my local repo here is surely out of date, so we're going to need to pull. And we'll probably need to add kmatch as a remote. I don't think I have one set up yet for that. So let's just start with, I don't know, I'm kind of superstitious, I guess. I just like to go back to adafruit main. I don't think it's really necessary. You could do it from any branch you're on, but I like to go back to adafruit main and then pull, and then, yeah, it's been a minute since I've done it, so it's probably going to take just a second here. Let's we can CD this around a little bit. We're going to be in the Raspberry Pi, and let me get a list of the boards. Updating, that's still running, interesting. Workspace, did it finish and it just is not? No, it's still running because these are gray. Give it another second here. Oh, we can't apply this patch because it's a directory. This, yeah, I get this sometimes. This has something to do with the submodules, I think. It's going to pop up a bunch of these. If anybody knows why this happens or how to stop it, definitely let me know. I think what I need to do is run those update. I like to roll back. Yeah, I don't know really. Let's go rollback. Rollback failed. That's nice. Okay. Let me grab those. I don't have these commands memorized yet. One thing I'm going to do is add these to my, let's go building CircuitPython. One thing I'm going to do is add these two commands to my touch deck. That way they're always within arm's reach and I don't have to memorize them. I think this is what I need to do though. We'll see if it pulls a little more normally after this. If not, we could always reclone, I guess, too. I'm with you. I like git pull from matching main branch. Yeah, it's just something about it feels like it's more likely to work. I don't know. Git. I've gotten a lot better at Git, but I'm still kind of like every now and then Git goes so totally sideways on me, and I get like super tangled up in it. And so I kind of like find the exact series of steps that works for me and then always take that exact series of steps. Okay, git submodule commands are a mess trying to understand what it does. Yeah, I don't necessarily know either. I mean, at a high level, I think it's updating the repos that are like linked into the core, and most of those repos that are linked in, I think, are for like to get frozen into modules. So like the Circuit Playground Express, for instance, inside the build for the Circuit Playground Express, it gets a frozen copy of the Circuit Playground library. And so there's a bunch of, similar type of ideas where boards get stuff frozen in, and I think that's what those are there for, most of them. Some of them, like, ESP IDF, that's for building, but a lot of them are libraries. Okay, it did do a success, so everything seems to be looking good. One thing I'm going to do is this. I don't think necessarily I would need to do that because I already pulled. But there's no harm, and I don't think I have a remote for Kmatch, so let me add that. Get remote add, I'm just going to call it Kmatch98, and we need to get the URL. So we'll come here, and is this the base URL? Yeah, okay, so we want that here. Get remote add Kmatch98, yep. Okay, that one we do probably need to fetch. There we go. So now we want to grab that branch, which was bitmap dirty something, bitmap dirty improvements. Yeah. And you can do it from command line. I'm not sure the exact command, maybe it's just checkout kmatch/, but I like to do it this way. So I'm just going to find it in this list here, checkout. There we go. So I'm in ports Raspberry Pi, and I want to check to make sure that we have the right code. So I'm going to go find this file and make sure it's updated, because again, I'm kind of superstitious, so definitely should be, but no harm in trying it out here. So that's bitmap tools init-c, which is in this shared module. So let's check that out real fast. Shared module, bitmap tools, init-c, and we're looking for a couple +1s around line 198. Yep, okay, so that's definitely got Kmatch's branch here, so we need to build, which I don't do very frequently, so let's see if I remember. I think it's just make, well, you know what, let's see if I have made this before. Let's start there. No. Okay, I don't, there would be like a build whatever folder right here if I had already made it. So there's not one, so I don't need to clean. So I do need to know the name of the board that I want to make, which I don't know it off the top of my head, so we're just going to ls boards, copy that, feather RP2040, that's the device we're using, and then it's just like this, I think, make shouty board equals paste. And then you can tack more stuff on there if you want it to, I guess, flash maybe, or program automatically. I tend to just run make by itself and then go and grab the UF2 file afterwards. So let's let that run for just a minute. Let me get my preview back here. Another thing maybe we'll do is run the current release. Beta 4 got released yesterday or the day before, like just a day or two ago, so maybe we'll run that one as well. We can compare that one to this one here. Boy, I don't want to jinx it. I'm surprised it took that long to build. I've been getting fairly quick builds on this computer, though. Maybe it's because it was a clean build. But it did succeed, it looks like. So let's go grab our firmware. Ports. Raspberry build. So here's this build folder that it made, build adafruit feather, and we want firmware UF2. So open that up, and then we'll go side by side here with the camera so you can see what I'm doing. Okay, we're gonna go to bootloader mode, which is double click on reset, because I have installed the UF2 bootloader, or maybe this one came with it. I don't remember now. No, I think I had to install something, because the first time I did it, I had to use the boot select button, but I don't have to do that anymore. Okay, so I found this drive here, RPI RP2. That's our boot drive for this device. So we just copy firmware UF2 right onto there. That's going to do its thing. It'll be a little blinky on the back somewhere maybe. Looks like it's done already. And so it will reconnect. And Moo will see it. We can connect to serial there. And we can check out this thing here to see if it is in fact the the build. So it says dirty here because it's just built off the shelf or whatever, right? It's not a real release. It's just custom build at this point. Somehow maybe we could match up this hash. I'm not entirely sure. Not entirely sure how that part works. Oh, I see it at the beginning here actually. So G9B18893 9, so the G is not there, but 9B18893, so you can tell there this is the version we're running. So let's go ahead and save that test code, or maybe it's already saved, it looks like. One thing we need to do though is we're not using board.display on this. We have a featherwing, and the featherwing is a separate board. Well, I mean, not a separate board, well, it is a separate board too, but it's a separate display. The display is not built in, therefore it's not on board. So what I'm going to do is, in order to make this touch deck project, I actually made, whoa, that is not where we want to go at all. Featherwing GitHub, let's try that. No, this is my thing. Gosh darn it. I don't know, I should just go to these pages normally instead of searching. Featherwing, this is a helper library for a bunch of different featherwings, and what I did for the touch deck project is I made a new helper for the 3.5-inch featherwing, which is the one we're using. So I already have it on my device. What's the thing I need? I think what I need is the example code from that. So let me just find my branch here. I'm just going to click through to get to it. Going to go to examples. There's a new example for it, and I'm just going to take the beginning of this because that will set up my display for me. So there's that, and then once you initialize the featherwing, you just go like this, tft featherwing.display. Super easy. Anything else? I don't think so. Well, true. Yeah, let's give it a try. I'll get the camera. Maybe we'll go, why don't we do these switched around? That way the chat is on top of the bottom of the camera screen, which is already blank anyway, instead of Moo, which is the serial. Okay, so we're in REPL. We can break out, and we also need to save actually CodePy, so let's do that. Here we go, TFT featherwing starting up, and there is our little bitmap. So it's kind of small, but you can see it there changing some stuff. I'm not entirely sure. I haven't read through all the sample code, but it looks like it drew a teal box. It made a red section, kind of filled it in with blue. It's drawing some little diagonal lines in there now, filling in the middle. And maybe one thing we'll do is print finished. That way we can see in the serial console that it's done running all the particular tests in here. And in order to make this look a little bigger for the stream, why don't we just scale 3? See how that looks? Yeah, there we go. That's a little bigger. We can maybe even go a little more than that if we want. So it's filling in red section there. Diagonals. Ooh, those ones looked a little odd. Let me zoom that up just a little bit more, and also let me catch up on the chat. Let's do this one. What is this? What is this from? This is oh, I think it's like a cartoon. I think I recognize that cartoon. Translation has come to an end. Oh dear. Yeah, that does sound ominous. Okay, we got some ideas on Git. Git pull the main branch, Git fetch likes, and then rebase. I'm scared of rebase. I try not to touch it because the few times I have messed with rebase are some of the times where Git has gone super sideways on me. So I'm scared of it. One of these days I will work up the courage though to try it out again. How's it going, K-Match? Thanks for joining. Firing on all cylinders. Yeah, some days. Got to get the coffee in, you know. Okay, caught up there. Yeah, how's it going, K-Match? We're testing out this, you probably recognize this, we're testing out the bitmap dirty improvements, and I'm using this test code actually that you wrote, so thank you for posting this up there. I'm going to scale it up a little more so that it comes through on the stream a little better, and I'm going to take a closer look at that diagonal section because it did, I'm not sure what it's supposed to do, but it was looking a little bit odd to me. But I also don't know which part of the code it is. Maybe this one. Bitmap 1 into the 2 corners. Okay, let's let it run again real quick. Did I scale that more? Yeah, 5. Let's try 5. So let's see if maybe we can see what it prints when it's on that section. So we got slow direct write, fast, 12. Dual roto zoom. Is this K-Match? Is this supposed to make an X? One of the lines bottom left looks weird due to roto zoom. I think it's integer rounding. Let me just take a closer look through the code here and figure out. We'll just walk through the logic because I'm not sure what all is actually going on. So we got our group where we got 2 tile grids. We're showing it. Nothing prints here yet because it's just created up here. Bitmap 0, bitmap 1. It's got 5 colors in it. Bitmap 0 is 2020 pixels in size. It's filled with color 3, so that's where we get our initial red from. Or teal, it's teal. We have a 10 by 10. Creating a palette, that's our 5 colors. Both bitmaps use the same palette, okay. Tile grid 1 is 10 pixels further over and down. Fill bitmap 1 with color index 2, so that's filling it to red. Direct write 0 pixel, so change 1 pixel to color index 0, which is red. Sorry, I think a moment ago I said red and it's actually blue. This one up here, fill 2. Yeah, palette 2 is actually blue there. So that's gonna fill there. Oh yeah, no problem, no worries. Thanks for checking in. Okay, match. One of the lines bottom left looks weird due to rotozoom. Okay. So let's just keep stepping through this. We filled it with blue. We painted 1 pixel with red. Direct write pixel at 1, 1 to red also. And so in this case, the difference is this one here is using only a single lookup in the index, so that's looking it up just off of its index as though it were a list, whereas this one down here is using a tuple. I think technically that would be a tuple, and therefore it's X and Y, so it's just a slightly different way to kind of, you know, say which pixel you're trying to access out of that bitmap. Slow direct write, so looping over width and height, just setting current width and height to 0 index, which is red. Small sleep in between there. Then our delay. So fast write. Same loop, setting to color 3 this time, which I think was teal. Sleep again. Slow direct write. This one is looping over width. Okay, so this is drawing a diagonal line here because it's going to loop. It's looping over the whole width, but it's always going like I, so it's going to be like 0, 0, 1, 1, 2, 2, 3, 3. So that's going to make us a diagonal line. You know what? Let me just run this up to here. Let's like freeze it here and see what it looks like. Save that. Let's see if we can get this a little closer here, maybe. Okay, changing colors. Here's our slow bitmap write. Here's our fast bitmap write. Is like instantaneous. Okay, so here's our diagonal. I wonder though, should it be all the way top left corner? Because I think 0, 0, 0, 0, I think would be the top left corner. Let's try this on the release CircuitPython and see what it does there. I think I have that downloaded already. Maybe not. Well, I'm sure I do, but it's not at the top here. Maybe this one. And that's just got a hash in it. Let me just download one to be safe. So CircuitPython.org, I mentioned that earlier. This is where you can go to get your release of CircuitPython. We're gonna go there, downloads. We want Feather RP 2040, Feather RP, and we'll grab, let's go with Beta 4. That one just came out the other day, so it'll be good to get some testing in on that. Oh, nice. 3D printed PCB holder. Let me, can you guys, well, what does that look like? Are you seeing that? Yeah, you are kind of, okay. Dang, I like that knob. Is that holding it does it like screw in and then like pinch down on the PCB on the edge there? So and is it holding it like an inch or so or whatever up in the air? This one, okay. Let me go to this link. Screws down. That is awesome. I never seen a holder like that. Huh. That's a really smart idea, though. I mean, like, it's real simple. I really like the texture. I'm a sucker for interesting textures. I wonder how well it prints. I mean, it looks pretty good on this one. I might have to make one of these things. This is pretty nice. Let me throw that up in this browser for later. Okay. Hate when boards move. Yeah, it's rough, man. Oops. Includes the math and Greek symbols. Got some, got the latest and greatest icons from JP. Let's open those up real quick. I'll give you guys a peek at them. JP made some math icons with mathematical symbols. They're looking pretty nice. I mean, all of the icons that JP made are looking pretty nice, quite frankly. They really make the touch deck look super amazing, all these nice icons. So these math ones here are the new ones. It looks like there's some other new shortcut launcher ones as well. Chrome, calculator. Ooh, those camera icons are looking nice. Top-down camera. Man, this is awesome. Huge shout out, by the way, to JP for making all these amazing icons. Code is my speed. I can do a lot of amazing things with code, but I do not have the eye for making stuff pretty like this. And this really makes the touch deck project look super nice. Anyway, let's get back to where we were here. So we downloaded beta 4. Let's go find that. Downloads. Is that it right there? Wish it were just a hair shorter on the name. There it is. Okay, that is beta 4. Let's run that one. Copy that. Go back to the camera here. Double click it. Go to bootloader. All right. Did we get our bootloader drive? Copy that. Yep. Paste it there. You know what's interesting? This one doesn't have the old UF2. It has info, but not the old UF2. The other devices, they show the UF2 there. I find that interesting about the... I'm sure it's just a difference in the RP2040. Okay, so we copied that. That's working. Here we go. This is running. It's our slow pixel. There's our fast pixel. There's our diagonals. Okay. So it is the same, so that's good. Let's just double check here. Yep, that's our beta 4, so that's definitely the same. Okay. I am curious. I guess it's because it's tile grid 1, maybe. I guess tile grid 1 is this whole section, so that's what it is. It's 0, 0 of tile grid 1, which is in the center of tile grid 0. That's why. That makes sense. Let's get our camera side by side going here again. And let's get that like that. Okay, so that does make sense why that's in the center. So that's fine. And let's look at the next one after that here. So we'll just drop this a little lower. This is doing auto refresh false, fast direct write to light blue. So it's turning auto refresh off. It's changing that same diagonal of pixels to be no longer red, but instead teal. And then after it gets done, it calls refresh. There's slow right, there's fast right, here's our diagonal, and there's our fast diagonal. So that's nice. It does make it look quicker and nicer to the eye because you don't see the individual pixels. They kind of all go pretty much at once, which is actually something we are trying to do in the touch deck. So I will probably be looking at that technique of using turning off the auto refresh, turning it back on, because we want to make it to where those touch deck icons don't pop in individually one by one like that, but instead, like, you know, get them all loaded up and ready, and then once we're ready to show it, kind of like reveal the whole screen all at once. And that looks like what it's doing here, so maybe we can reuse that. So let's keep going here. We'll add one more. Quotes. This one is gonna go again on the diagonals, setting everything back to 0. So red, I think. Okay, that looks pretty good to me. Next one says blit from, actually I'm not sure on blit. I will need to see the, I'll need to take a reminder peek at the docs. I forget, I think it goes, yeah, I don't remember which one is to and which one is from. I think we're going into the one that we call the function on. I think that's how it works. We want docs, bitmap, blit. So source bitmap is the one we pass in. So yeah, we're going from pixels from the one we pass in to the one that we called the function on. So it will blit from 0, 0 in bitmap 1, I guess probably defaulting to the end, because we have X and Y. Not sure what the defaults are. Must be going to the end though, I think. Rectangular bounding box. Oh no, okay, so we have XY, the location the location of the one we paste in. That's our XY location of the one we paste in, and then X1, Y1, X2, Y2, that is the rectangular region that we're actually taking out. So then my guess is if those are not passed, it probably just means the whole bitmap. So take everything from bitmap 1, paste a copy of it into 0, 0 in bitmap 0. So we should end up with the diagonal going all the way across the big bitmap, because we have the bottom right corner diagonal now, and we're going to blit that up to the top left. Okay, quick fill. Well, no, this is slow fill. This one's quick fill. Diagonal, blink it back, draw it again, blit. It's looking good. Okay, let's add one more. Let me catch up on the chat too. Display auto refresh false is a good way of holding refreshes and doing a bunch of drawing. Downside is it means, oh, that's true. That's true. In the case of the touch deck, though, we can do it because I'll do it at the user code level inside the touch deck project. So like probably in my load layer function, it will say auto refresh off at the beginning, do all the stuff, auto refresh on at the end, or well, and call refresh once we're ready. Or should that go in grid layout? If grid layout has access to, well, but we append those children one at a time. Yeah, we don't want to do it inside grid layout because we want to wait till after all the children have been appended. So yeah, user code is where that will be. What IDE should we use for CircuitPython? I used VS Code previously, but that one didn't like it when the firmware crashed and I lost the firmware I was working on. Oh no. I use PyCharm, so PyCharm Professional. That's the IDE that I use. I don't do a whole lot of core development, I will say. You know, obviously the core is written in mostly C, so PyCharm is a Python IDE. It does not necessarily have a whole lot of stuff in it for making C easier to do. We got a couple other suggestions, VS Code and TO. I have used TO a little bit, and I do like that for the terminal connection. Dealing with display and refresh at user code is okay, but it will limit the ability. Well, I think we could turn. I mean, the only time I would need to mess with refreshing is right when I'm rendering a layer. So if I just put everything back how it was, after that, maybe the I think the animations should still be able to work. I think. Don't use the I don't use the terminal built into VS Code. I have a lot of problems on Ubuntu with that. Yeah. I don't have any experience with VS Code at all. I know a lot of folks like it, and it does look pretty nice. I think I can get it for free on this computer, but I've just been a PyCharm user for long enough that that's kind of like my go-to at this point. I guess I'm just not drawn to try to change to anything else. Let's see where we're at here. So we blitted. That blit seemed to work fine. Why don't we grab one more chunk here in our sample code. Save that. Let me pull the camera back up too. There it goes. Do have a license for JetBrains IDEs. Would prefer to save the files on a local disk. Yeah, that's one thing is I don't use PyCharm when I'm writing to the device. I tend to use Mu still for that. Like you can see here, I have Mu up on the left. And so yeah, I don't tend to use PyCharm for that. I think there is a way you can do it. I think there's like a setting you need to go and turn off. I don't know what it would be called, but like auto writing or whatever. Because in PyCharm it basically saves automatically all the time. You never really have to actually do Control-S to save. And we don't want that with the CircuitPython drive because it will just reboot all the time. So somehow you can turn that off. I'm pretty sure there's something in settings to do that, and then that would be the thing I think to do if you wanted to use PyCharm directly. Sometimes animations require fill with blanks and then redraw something. If auto refresh randomly hits the blank fill clear and the redraw, it can cause the screen to flash between the blank fill clear and the redraw. I see. So if auto refresh is on, it can cause it to try to refresh essentially when you don't want it to. But the animations maybe could turn it back off if they needed to, I think, possibly. Put VS Code on my hate list because by default it doesn't prompt. Oh, yeah, that's rough. And it doesn't autosave either, so you can like just lose files if you close it. That's no good. Okay, what is going on here? So to make it look not perfect. So is it dual roto zoom? Let's just make sure I understand what it's supposed to do. Bottom left should be rotated 90 degrees. So one thing is I have not played with RotoZoom very much yet. I did like the most basic testing on it when the PR was there, but I haven't played with it that much. So we're saying destination bitmap is 0. OX and OY. 1/3 of the width over, no, 3 times the width over 2. Contents are there as if you saved it, so it like saves it as a cache, but not in your actual file, maybe. Let's start with one of these only. Angle 11 over, what is that? No, 11 over 7. That's mathematically significant somehow. Is that pi? No, it can't be pi. 3 point. Let's do this. Let's get one of these going here. Let me get the docs also for RotoZoom after this runs. Yeah, that definitely sounds no good. I have not tried out VS Code, but Johnny, you're definitely scaring me away from ever looking into it too much more. Okay, there's our diagonal. That's our second one. Okay, so it drew this one up there. So that is actually what it's supposed to do, I think, this one. But the other one is the one that is looking imperfect due to the rounding errors, possibly. Let me pull the docs for RotoZoom. It's in bitmap tools. Okay. Insert the source bitmap region into the destination bitmap with rotation, which is angle, scale, and clipping. Both on source and destinations. So we are calling this with destination bitmap is 0. So we're pasting into the larger bitmap. They named it a hot exit, just to make sure you can't find the stupid settings. Yikes. OX is horizontal location in the destination bitmap where the source bitmap point PXPY is going to be placed. So we're going width times 3 over 2, so we're going 2/3 of the way through the screen. I think that's how that's going to work. 2/3 of the way through X, which does map up with maybe what it looks like here. This looks like it's possibly 2/3. Next is OY. So that one's saying just height over 2, so half of the height, which is vertical pixel location in the destination where PXPY gets placed. Source bitmap is bitmap 1. So this one doesn't do any rotating that I can tell. What is the region that it takes? So I think we would, so we're not doing clip. If we wanted to change the region, we could be using clip. Let me just play with this a little bit. You know, I almost want to start a new example and just play with RotoZoom by itself a little bit. Because I haven't done that yet. So let me save this off. This is going to be dirty bitmap test, dirty bitmap improvements test. And let me back up some of this stuff here. So let's get 2 bitmaps of the same size. We can still use one palette, that's fine. Keep my group. Got both tile grids. One thing I'll do, tile grid 1. Let me let's move tile grid 1 before we ever show it, and we can leave it at Y0, and let's just make it, it's 20 pixels. So let's go 30? No, 40, so that we have 10 pixels between. And before I save this, I need to rename this back to CircuitPy. Okay. So that's going to show it, and then let's going to comment out the rest of this stuff. Eventually I'm going to come back and delete it, but I'm going to copy paste a little bit more of it before I'm all said and done here. Okay. So this will draw one teal bitmap and one red bitmap. and they'll be on the same Y line but 10 pixels apart from each other. Scaled though, so 50 pixels apart from each other, I guess, because of the way that I'm using scale 5. Okay, so we got our 2 bitmaps. Let's make a line in one of them. And let's make them the same color, actually. So for the range, then set 0 current pixel let's make a line in the center-ish. Okay. And now let's roto zoom it over to the other one. See what it looks like. So roto zoom it. Destination is bitmap 1. Source bitmap 0. OX and OY. So horizontal pixel location in the destination where the point PP is placed. So let's try 0 and the same, 10. So this has just those parameters, destination, source, OX, and OY. So let's see what that does. I think this would copy the red line from the left one so that it's also in the right one, which we could also do with blit, but we're going to rotate it in a minute, which we can't do with blit. Okay, not quite. So it did copy it into that other bitmap, but it only copied half of it. And this is because, why? Do I need a P? Feels like I would need a PX and a PY. I think I'm gonna do is make this a little cleaner here on some different lines. Would this still be the same? Oh, I did this wrong. P. Okay. Okay, and we're not using clipping right now, but I am kind of curious to play with clipping. But I think I want to mess with angle first. So, angle in radians. It's been too long on geometry for me. I do not remember radians. I guess that's where that 11/7, that must be... I thought that sounded familiar. That must be a constant for radians that's common. Nice. No. Okay. There we go. Sorry about that, folks. Yes, geometry. Radians is equal to degrees times 2 times pi over 360. So if I want 90 degrees, then I would want 90 degrees times 2, so 180 times pi, oops, and divided by 360, and that would get me 90 degrees. I suspect my px might need to be different, but let's see what this does by itself. Okay, so that did rotate it, and my px does need to be different. I think if I wanted it to go in the center vertically here, this would now be like this, 10, 0. No. I mean, it wouldn't be these ones, would it? Factor out the 2. It would be those ones. Let me take a look at these again real quick. Horizontal pixel location in the destination bitmap where the source point of px, py is placed. Okay, so it is the destination. That makes sense. Vertical pixel location. So we wanted it, the destination we wanted it to land at was x10, y0. And then the point that we wanted to land there from the source was x0 and y10. So we rotated it to 90 degrees, and we made sure that this point on the far left here is now in the top center here. Reminding me of missing points. Oh no. That would be radians. Oh yeah, you could, that's a good point. You could cut the right side of the divided by sign down by taking out the 2. Although in my case, I factored my 2 into the angle that I wanted. So I wanted an angle of 90, and I just put 180 to factor out the 2. But you could do it from the right side of the divided by sign also. I think that's correct. Okay. This is making sense to me. Let's play with some of the other stuff it can do. And while I'm here, actually, let's swap back to the test firmware, because I'm on beta 4 right now, because I wanted to see if it did the same thing, and it did do the same thing. But now I want to go back to the test one, because I want to see, I want to be testing the new stuff, basically. Math dorks are cool, I agree. RPy2 feather firmware. Okay. That pasted, we got CircuitPy back. It drews the same this way, so that's definitely good. Let's play with the other stuff. Let's try scale. So I could make this line thicker by doing scale 2. Is that true? Not without a comma. Yeah. There's 1 pixel off there at the top. But that's because I would want to be at 9 now? Is that true? No. So maybe this is another instance where possibly the scaling, well, possibly the rounding is getting us. I tend to think in radians. I'm a degrees person myself usually. Although truthfully, I don't do geometry that well. No matter which kind of degrees or radians we're talking about. This is kind of like, you're seeing my process here for geometry. It's a whole lot of like guess and check, like run this thing, see what it does, and then after I've stared at the output enough times and tinkered with the input enough times, eventually I kind of have a picture of what everything is doing. But it takes me a while of just tinkering and looking. Could we get... Whoa. Okay, just got a ping catching up in the other Discord there, that's fine. Would this be... this would not be 9 to get that top pixel, I don't think. That's going to do something else entirely. In fact, this might copy teal. Oh, interesting. It took the other pixel out of the top. You can go negatives. You can, and that fixes it. Can you go negatives that are outside? Yes, and that doesn't seem to be a problem. So it's scaled by 2, so it's twice the size of the square right now. Could we go... So do we have to subtract it pre... So we're scaled by 5, but that doesn't matter. We're scaled by 2, and that does matter. Our thing is 20 pixels. If we go minus 10, is it halfway up vertically? No. Minus 20? Still no. Interesting. Maybe these, if they're negative and they're outside the range, it just gets ignored and sets to 0. Oh, no, because I managed to move it all the way there. So, 30. So I had to do 30 because the bitmap is 20 pixels tall. It's scaled by 5 after that, so it's actually 100, but that part I don't think matters. So it's 20 pixels tall. We're gonna say it's getting scaled by 2 to go up to 40, which means if I want it to be halfway, if I want it to only show 10 pixels, which is what I've got going there, then I do need to go minus 30 because my size is going up to 40 here. So that does make sense. Let me put this one on 10, and that's going to scooch it just a hair to the right. Is that going to scooch it to the right? I feel like somehow I ended up left by a pixel from... Yeah, that did scooch it to the right. And the reason why I changed the Y value and it actually affected the X location was because of the angle is changing it by 90 degrees. So that makes sense. Okay. Let's, what else we could clip? Let's play with clip a little bit while we're here. Thank you for bearing with me, guys, while I tinker with this. Hopefully this is interesting and you all are learning something as well. I know I'm learning a lot. Oh no, did my chat freeze? No, I don't think so. Or did I scroll it weird? No, okay. Let me catch up though. Rotozoom, if you want centered rotation, it's sometimes easier to arrange everything relative to the center of both bitmaps. So my point is on the left edge of my line, but if my point were in the center, then I would rotate around the center, and then maybe I would not have to mess with the XY location at all, I think, at that point, because if it rotated from the center, it would be in the right spot. I think that's what K-Match is saying there. 0x, 0y is the center of the destination, and px, yeah, px, py is the center of the source. Degrees equals pi over 180, and angle equals 90 times degrees. Okay, so let's try it that way. If we could center both of them. So if we said 10 10 10 would be the center, because it's 20 by 20 total. And then let's take the scale back off for now. Let's go scale 1. And then if we put 10 10 here, it would just rotate it only and leave it in the center. Yeah, although we do have that one, we do have the 1 pixel at the top. What is that coming from? Because then if this were 9, it would go all the way up, or no? Yes. And if it were 8, then we would have 1 pixel clear at the bottom. Yeah. Okay. 9. I think maybe the reason why we're getting that 1 pixel off is because our thing is an even number of pixels, so there's no center pixel. We're always going to be off by 1 from the center. Whoops. And I think that is where that extra pixel might be coming from. So to test that theory, I'm going to set these to 21. And then we will use ten and 10 and 10. Is that right? Because 10 is in the center. Still off by 1. Interesting. This may be... And if I go here, 9 is still the same. And then is 8 still the same as well? So 8 gives me 1 pixel clear at the bottom. Yeah. So changing both to 21 didn't really make a difference. So it's not, it can't be really what I was saying about being even size that's causing that. Let's double check that it works the same with the current release, beta 4. Thank you. Which we have downloaded somewhere. Feather beta 4. Alright. I'll mess with this a little bit more and then we'll move on to the next thing I'm going to work on today. But this has been really good for me because I have gotten a chance now to learn a lot about how this RotoZoom works, which is a really neat feature. Okay, there's that. Yeah, it does look the same. And it does work the same here. If this is 10, we're going to get 1 clear at the top. And if it's 8, we're going to get 1 clear at the bottom. Let's just verify both of those things. Yep. Here's our 1 at the top. Here's our 1 at the bottom. Okay. I think I got a pretty good grasp on that now. Let me try something trickier. So let's go instead of 90, let's make it 45. So it's going to go to diagonal. And since we centered it, it should, yeah, be in the middle of the square like that. And it won't go all the way to the end because something to do with Pythagoras makes the line longer on the diagonal, I think. So we could figure out if we wanted to make it go all the way what the distance it needs to be is, but I don't necessarily need to do that. That's looking pretty good. So we could also go can you do negatives? Can I just tack on negative so that it will turn the other way? Yes, you can. Rockin'. Okay, so it does. It did draw it a little bit differently. It's like kind of thicker on the bottom half than it is the top half, I guess. I wonder if, so instead of negative, if we wanted to go all the way around to the same thing, it would be what? It would be 360 minus 45? Is that right? Yeah, I think so. Which is 315 maybe? Yeah. So this was times 2, 630. Does that look the same? Interesting. The line geometrically is the same, but the pixels got swapped. Now the thick part is on the top right and the thin part is on the bottom left. Scale by, I don't think we can scale by fractions. Can we? Maybe we can. Maybe I'm wrong. Let me check here. Oh, it is a float. Wow, I really thought that was an int. So if we go square root of 2, math, square root of 2, and we're still in the center, so that will make us a diagonal that goes all the way. Nice. We have the same kind of off by one thing with the bottom left, but maybe that's now, maybe this would now need to be 10. Yes, that went to 10 and that got us there. It does have like one hitch kind of here in the middle, and that leads it to be off by 1 pixel in the bottom corner. I think that's probably the rounding that K-Match was talking about. RotoZoom float scaling is good for fonts. Yeah, that's awesome. I'm super stoked that we have the ability to scale fonts in between. Like, scaling fonts by integers is nice because you can make them bigger, but scaling fonts by floats is awesome because you can make it fit kind of perfectly in your interface. If you're going only by ints, like, you know, you don't always want it to be twice as big or 3 times as big. If you could go 1.5 times, though, that's amazing. And down as well. Yeah, good point. If you have a font that's bigger and you want to scale it down some, that's true as well. Okay. I think that I have got a decent grasp on what is going on here. Maybe one more thing I want to play with actually is clip. So if I added 1 more pixel to my source bitmap, that's red. So let me do that. Bmap 0. And I want to go. I want to put 1 pixel like 2 rows up from the line in the center. So X is 10, Y is 7 or 8. Let's go 7. And this is red, so 0. Let me make sure that that draws my pixel. Okay, so we did get our pixel there. That's nice. And, you know, again, we've got some rounding stuff going on here. And especially scaling, too. Like, the other thing is I bet it may also be slightly different if this scale was different. So it's going to be super hard to see, but maybe with this... I don't know, it's not really going to focus on anything that size, and I can't even really see with my eyes. It looks like they're still different sizes though, so it's not to do with this scale. Let's let that run at the bigger one again here. Okay, and so now if I used clipping, then I could clip it so that my destination one ends up with only the diagonal line and not the extra pixel. That's what I want to try to do, just to see if I can, because I think that's what that's going to let me do. So if I went source clip, the first corner of the rectangular source for the clipping region, the second corner. So conceptually, I need to, those are what, points? Yeah, each one is a tuple, so it's XY point. And what I need to do is basically make it so that those points draw a box like, let me do it like this here. We can go screenshot this and then draw a box. My green box is kind of clunky here, so it's going to be a little big, but you can get the idea, I think. What I need to do is define the points so that my rectangle is like this, so that it leaves out that extra pixel, but includes that bar there. So let's give that a try. And that was what? Source clip 0. Source clip, is it underscore 0 or just 0? Just 0. This one is a tuple, so whoa. And we want x of 0, y of 9, or maybe 8. Let's do 8. And source clip 1. Also a tuple 10. No. 20. Because our thing is 21, so 20 is the far right index. 20 for x, and y is 11 or 12. I guess it doesn't matter nearly as much on the y because we don't have a dot down there. Let's go 12 though. So will that take away the little pixel on the right? I think it might. Oh, but not without commas. It sure will not. Okay, let's give this a try. Yes. Okay. Awesome. Okay. This is really cool. Huge shout out to Kmatch for making this. We can do so many amazing manipulations with this. This is like Swiss Army knife of bitmap copy pasting. And I imagine I still am really only scratching the surface. There's cool stuff like I didn't play with skip index at all, which you could use for making transparent pixels or doing some fanciness with rainbows if you wanted to make it see-through maybe. You can do a destination clip as well. Destination clip. What if we would look, it would look weird, wouldn't it? But what if we do what if these were the same? Would it give me a weird squashed diagonal in the middle? Kind of. Okay. It doesn't squash it. It's not like gonna stretch it to fit that clip you give it. That, well, I mean, of course it's a clip. It's not a stretch or a scale or anything, so that makes sense actually. But so it just cut it. It cut everything that was not in that box of the resulting bitmap. So our resulting bitmap was our diagonal that goes all the way. It cut everything other than this box out of it. So that makes sense. That's a way you can take away sections that are outside of the rectangle that you want in your landing zone. Okay. Okay, this is really nice. Really nice. Okay, that's looking pretty good. Let me take a look back at that page. So I did a bunch of playing with RotoZoom. Nothing. Okay. So I do think the test code, it was definitely working the same in the beta release as it was in this test version that came from Kmatch's branch. So it seems to be good. We do have the rounding issues that Kmatch has mentioned. I don't know. I mean, that might be, there might not be a lot we can do about it. I don't know under the hood exactly where we're running up into it, but if it's, you know, like geometry, mathematics kind of like scales infinitely small, you know, you can always have a smaller subdivision of a point or a number. But on a screen, we're limited by pixels. Like, you can only make your fraction go so small, and then you can't really paint half of a pixel on a screen like this. So the rounding might just be, it might just be a fact of life, honestly. If you want it to be perfect, then you need to make sure that your inputs don't get rounded to having super long, weird fractions that can't be drawn perfectly into the bitmap, into the XY pixels. Let me catch up on the chat here. Anti-aliasing, that'd be fun. In RotoZoom, I think it converts the type from float to int. Don't actually know how the type conversion does the rounding. It may round to the nearest even number. Need to visit it and see if we can make it more predictable. This algorithm is from some ancient Amiga computer, from folks that were doing all kinds of cool conversions and trying to do it fast with limited processor and RAM capability. That sounds pretty familiar. Yeah. There's a great opportunity to look back at some of the first like game systems and graphical computers and stuff, because they had to do a lot of tricks like this to be able to display their stuff at all with the machines they had. And now we have much more powerful computers, but we're playing with microcontrollers here, tiny little ones. So we can kind of take some of their tips and tricks and apply them, get a lot out of it. Looks like Johnny worked on that stuff. No anti-aliasing right now. Zeppler mentioned wanting to have a look at it. I think it would require some more palette tweaks and additions at the same time. Got the Jedi texts going in here. Nice. Yeah, that would be cool to have. I did not have anything like that. That would definitely be real fun though. Mess around with something like that. Commodore 64 and Amiga. Started out on Commodore and got to move. Which library am I using for the touchscreen? Yeah, that's the one right there, STMP. It causes a hard crash when you initialize it. In your serial console, Dexter, do you see, if you go to Mu and look in serial, do you see this error here? This is not GitHub. That'll take me there. This is the wrong library. What am I doing? Featherwing. So this error right here, runtime error, failed to find STMP 610. If this is the error that you're getting, what we found was that you can do a small sleep before you try to initialize the touchscreen. It seems like when the device boots up cold, it's not quite ready to initialize the touchscreen. It seems like the touchscreen driver is still waking up or something. I'm probably oversimplifying that by a lot. I don't actually know what's going on inside the touchscreen driver, but it's not quite ready for the microcontroller to connect to it. And when it's in that situation, it raises this runtime error. If this is the error you're getting, then you should be able, hopefully, to fix it by just putting a time.sleep in front of, like before you try to initialize the touchscreen. And what I did was, if you want to use the helper, if you have this same Featherwing, there's now this helper in the Featherwing library here. It uses this superclass right here, TFT Featherwing, and what I did was right in here we have put the time.sleep and then also some logic to retry once. So before we initialize it the first time, put a time.sleep of 0.8 seconds. We found that 0.5 was working for the devices that we tested it on. But we raised it a little bit higher. We went 0.8, just to be safe, because we don't know. It wasn't consistent on all the devices and all the versions, so we don't know if it might need to be longer for some other folks. So give this a try, Dexter. Put a little sleep there before you initialize the touchscreen. And if you are using this same exact Featherwing, then you can also make use of this helper class, the TFT Featherwing 3.5, in which case it takes away a bunch of the boilerplate. You can just initialize the Featherwing only right here, and you don't have to mess with the touchscreen independently and the display independently and all of that stuff. This sets it all up for you, and then you can go ahead and start getting your touch events right away from it. And the good news is, because we added that sleep into the library here, if you use this helper class, then you will just automatically be getting this sleep. You won't have to worry about it in your code. So yeah, that's my guess as to what might be going on with the STMP touchscreen there. Just a guess, how many tricks do you have to use on a 1 megahertz processor where you try to synchronize your code with electron beam on a TV display just to switch a register at the exact pixel point? Yeah. Ooh, look at that looking tiny little TV begun. That's a cute little gadget there. Tiny DIY TV kit. Oh, it's not a TV begun, it's a whole TV. Let me see this. Hold on. Let's put this over here. Whoops. Come on. $75, not too bad. It's a little 3D printed jobber there. Oh, that's so cute. Shipping March. It's for pre-order, but it ships pretty soon. Oh, it's sold out though. So coming back in March, okay. Huh. That's really awesome. Tiny circuits. Tiny circuits. Is that the thing? Tiny Duino. I think I got, yeah. I got some of these things at one point. Okay. Interesting. So they branched out into kits and stuff as well. Huh. That's really awesome. Okay, let me catch back up on the chat here. Code pushed to learn guide repo. Copy. Nice. Okay, sorry. I'm coordinating with JP a little bit here on the touch deck guide. Okay. Forgot to order a SAMD51. I'll add a delay and see if it helps. It is the Featherwing. It's a M4. Okay. Yeah. If I were you, I would just try to use the Featherwing helper. So one thing is it's not merged in yet. So you'll have to grab it from my branch. Which if you come to the pull request page here on the Featherwing library, it's pull request 68, and then if you click the branch right here, it will take you over to that branch that I've been working on. I think we could probably merge this. I know, let's see, Lamora asked for JP to check it, and I think JP did yesterday, yeah. So we could probably merge this, truthfully. I don't want to necessarily do it right this second on the stream, but maybe I'll do that a little later today. But for now, you could grab it from my branch right here, and then you don't have to worry about the pause. Nice. Okay. Where was I at here? I think I don't really have anything yet to report on this. Everything seemed to be working okay, but I did not go back and do I need to go back and check the progress bar. That was the one I noticed initially. And then the other thing we need to do is make sure that we're doing some of these ones with the quick updates, the for loop here, because this code, for some reason, the speed seemed to matter. It didn't really have trouble with label. I did a bunch of tests on label, and even like labels that moved around, and I didn't really have any issues, but then with progress bar is where we saw the issues. And what progress bar does is it has a real quick for loop that is manipulating all those pixels individually. So probably what I'll do is kind of expand a little bit on some of the parts of this test that Kmatch wrote, and make some more sections that do these for loops and have it just draw a bunch of stuff and see if I see anything weird going on. But I think that's good for now. We can move on to the next thing. Spend about a couple hours on this one, about 2 hours. I don't think I mentioned it back at the beginning, but these streams, they tend to go for I've gone for 3 hours the last few weeks. I don't really have a set time. It's just kind of whatever I'm feeling. 3 hours is about when I'm, getting ready and wanting to get up and stretch and stuff. So I don't anticipate very many of them going too much longer than that. But it really just depends on what we're working on the day and how I'm feeling. So that's where we're at on the time. Look on the other pages. Oh, nice. Yeah, we can do that. Display a layout. Sorry, I know you guys can't see what I'm typing here. Get one more and display a layout that removes the debugging print when it's laying out the grid. Today. Okay. Sorry about that. Yeah. Sorry, the sound from the microphone. I need to find a better solution for that. I don't know the best way to do it. I need to move it higher up or something. The microphone is very not good is not the word I'm looking for, but it picks up stuff really well. It's good at picking stuff up, and unfortunately it's a little bit too good, and it picks up, I'm sure the clacking is probably pretty bad on the keyboard, and then I think I know what you're talking about also, like when I put my hand down or when I touch on stuff, you can kind of hear like the bass drum going on, because it's like traveling through the desk or something. Yeah. So does it pick up the vibrations on a squishy surface? We can do that. Let me, I got a beanbag here. Let me do it this way. I got two beanbags here. Let me do it this way. Okay. I got it setting up on some beanbags now. Let me know if that ends up being a little better. Thank you for the tip though, by the way. Also, I didn't know necessarily that would help us out here. All right, where are we at? So we looked at that. We don't really have anything necessarily yet to put onto this review. One thing is, if I understand right, we are waiting maybe still for Jeff to pull in the latest changes from Kmatch. I think. And then I'll try, again, I'll try to do some more testing off the stream using these for loops. But this gives you an idea of what we're working on here. Next thing that I want to look at, I had a text file that says, yes, okay. Next thing I'm going to look at is also something else that, oh, we have a 1 here, so something happened. Let's scroll it back down and see. Kmatch commented live right here, 17 seconds ago. I found the one issue. Oh, new test code using image load and bitmap on this bitmap. Nice. Okay, so there's a new copy of the test here. Sweet. Thank you for that, Kmatch. What I am going to do though, the next thing we're going to look at is actually also something that Kmatch worked on. It is in display a layout library. Layout right here. GitHub. Here. So, back here, dial gauge. if you guys haven't had a chance to see this yet, definitely check it out. It's super cool. So you can see right here a little video animation of what it is. It's a round dial gauge. You can have different labels on it right here. So what K-Mesh was saying before is it uses that roto zoom, that function that we were just looking at. It uses that, if I understand correctly, it uses that to position these labels out here and turn them at these angles and scale them to the right size and all of that stuff. So this is really, really cool. It's super configurable. There's a ton of input options. You can change the size and the labels and the colors of the needle, the colors of the ticks, the colors of the text. You can really customize the heck out of it. You can change the angles for how far around it goes if you want it to go more or less. It's a really, really, really cool new widget. So I wanted to show off that this is here so that folks know that you can use it. And the other thing I wanted to do with it was just kind of play with it, whip up a little sort of real world example. So what I have are some stemma devices here, little stemma breakouts. I have this one is the wrong way. Let me turn that over. This is a SI7021 temperature and humidity sensor. So I figure we'll plug this in, we'll get a temperature and humidity reading from it, and then maybe we will, I'll show the docs page here in a minute as well. The docs page is amazing. We'll grab a reading off of this sensor, and then we'll put it into the dial gauge. And then because temperature and humidity are fairly static, I don't have a great way I can breathe on it or something to get the humidity up. But I don't have a great way to manipulate the temperature that much. So I also have here this one, which is a BH, get it to focus here maybe, BH1750 light sensor. So this one is also stemma. Here's the back of it there. And it's a light and lux sensor, and it has a range of 1 to max small int, whatever that is, 65,000 something. So we can use this one because I can just cover it to make it lighter or darker. Okay. Hugo's back. Welcome back, Hugo. So yeah, the docs page. Let me pull that up because the docs page is freaking amazing for this, if I could be quite frank. So let me go here, docs, and then it will list them here. So dial gauge right here, and then let's take a look through this. So here's our initializer function. Here's all the different parameters. I was talking about a bunch of these, but I'm sure I missed some of them. We've got, basic stuff like location and size, the amount of padding that goes around the outside of that dial gauge, how far the, let's see, dial gauge rotation in degrees. So this is how far, I think this is how far the ticks go. I played with all this stuff a little bit, but only once when I reviewed, so I might get some of them a little bit wrong here. Luckily, the docs, again, are amazing and going to tell us everything. But I think that's how long around the whole thing goes. And then start angle, that's basically where your 0 is at. So wherever you want your arrow pointer thing here to start. So this one starts here on 0, which is kind of like bottom left there. And that is the start angle. And then one of them has there's a minimum and a maximum value, which I believe then the maximum value combined with the, I guess it would be combined with both. The minimum value and the start angle then is calculated, I think the ending angle as well gets calculated by the max value. So the current value, this is what you set whenever you want to change it to a new value. So in our code that we're getting ready to write, we're going to read from the sensor, and then we're going to set the value equal to something that we got back from the sensor, or maybe we'll do a little math to turn it into a percentage or something. Display value, this one is set to true if you want to display a value label on the dial. So I believe this would add another label, and I think you can pick where it ends up maybe. That one in the example I think has this turned off. I'm not 100% sure, but we'll play with that a little bit once we dive into the code. The font for the value label. So if you want a custom font, you pass it there. If you want a custom color, you pass it there. If you want a custom format, even, you can put it here. So if you want, it to have like percentage signs or dollar signs or a decimal in the right spot or whatever, you can do a formatting string there. Here's our position. If you want to anchor point, move it by its anchor point. Oh, no, excuse me. This is the label. This is the value label. So if you turn value label up here, right here, if you have that on, then these are going to determine where that value label gets placed. So you use an anchor point and anchor position of the value label and define a spot around the edge. I assume you would want it on the edge of the dial gauge. Weblate gang missed you, yep. Oh yeah, we got a gang. We definitely got a gang going. Alrighty, witness protection and relocation. That was quick. But they're good at what they do, I guess. So more customization here. Needle, you can change the size of the needle. You can change the color of the needle. You can change the color of the tick marks. These are the tick marks that go around the outside here. So you can make those whatever color you want. You can change the major strokes, so like the ones that are bigger there with the numbers on them, you can change the size of that. The length there, you can set up the labels for those. You pass an array of strings, so you give it whichever strings you want to be these labels here around the outside. Let's see, a couple more here. Tick label scale. If you want those labels to be scaled to a different size, you can pass a float right here. If you want a different font for those labels, you can pass that one here, different color. Angle tick labels set to true to rotate the major tick labels to match their angle. So the way that these are rotated around to match the angle of the dial gauge, that is what's getting controlled by this Boolean right here, angle tick labels. If you want them all to be normal orientation for reading, then you could have this to false and they would all, I guess, just kind of fly out from the side there. I like the look of the rotated ones, definitely a lot nicer to me. So I'd probably go with true there. Minor ticks. Oh, interesting. You can set how many ticks you want. So the number of minor ticks per major tick, that's really cool. How big you want the minor ticks to be, how wide you want them to be, how long you want them to be. Background color of the whole thing, none for transparent, that's probably most commonly used. And then anchor point, this would be the ones where you are setting the anchor point and the anchor position of the entire gauge itself. So this would be moving the whole gauge around the screen. So you can see there's a couple nice examples. This is, I think, the same GIF from the PR there. So that's nice that it's in the docs. And then there's also a ton of these other images that explain how all the different stuff works. So like here's one explaining the start angle right here comes at minus 120 degrees, showing that it's going all the way around there to 0 to get it up to 50. And then the sweep angle here goes all the way around to 240 because we started at minus 120, 0 is up here, and then positive 120 would be down here, and the difference between positive 120 and negative 120 is our 240 there. So that's our sweep angle to go all the way around. Oh, what? No way, Blinka temporary tattoos. I had no idea that existed. I'm going to be rocking some of those with my next order. Minimum value, maximum values here. Here's all the different tick and color and label, everything for defining the size of the ticks, the major and minor, size and color there. Here's like a super long needle there, so you can have it clipped if you want to have kind of like a scrunched up top portion of it, but you still want to have a nice wide angle there. So that's really cool. Tons of ways to customize the way that your dial gauge works here. So, you know, this is like kind of the most basic one, the default looking one right here, and it looks super amazing. But you really can get any kind of dial gauge you can imagine. So I'm really excited to see what kind of stuff people are going to make with this for, you know, maybe car stuff like RPM type stuff. You can have that kind of a layout here, but really anything that, you know, air pressure or something like that. If you had a pressure sensor, like there's all kinds of stuff that use these gauges in the real world. And I'm super stoked that we can have a virtual one now and start building out, you know, mocks of those real world things that actually use those needles. So yeah, this is super amazing. Huge props to K-Match. Thank you so much for working on all of this. Yeah, fan speeds, that's another good one. I know folks like to do stuff, you know, if they got the fancy, you know, real nice computer, like they have fans that are super tuned, so that it's like, you know, showing you all the time like how fast it's running, so you know how much energy it's using, stuff like that. Voltmeters, that's another amazing one. I know, you know, if you're like analog reading something or something like that, you can have the gauge to show you what input it is. Okay, so yeah, this is super awesome. This is what we're going to play with. Again, I'm going to hook it up to one of these sensors, or I'll probably just go ahead and hook it up to both of these sensors while we're here. Again, I got one that's temperature, humidity, and one that's light. So the other thing we'll do is maybe test out using both of those at once. I haven't actually done that on this device yet. Okay. One thing though is I am going to need a real quick bio break before I dive into that. So I'm going to find OBS here. I'm going to put this back on the waiting screen, and then I'm going to run and come back in just a minute, and then we'll pick up with this. So there's that, and I'll be right back. Alrighty, and we're back. Let's go stream. There it is. Got some coffee going here. Let me catch up on the chat here. Oh, nice. Dexter tried out the Featherwing 3.5 and that's working. Awesome. Hey, if you're on Dexter, if you're on GitHub and you don't mind, if you have a second, will you leave a just leave a comment on this PR if you could. and just mention that you tried it out and that it worked for you. That'd be awesome. Thank you if you can do that. If not, if you're not on GitHub or something, or you rather not, that's totally fine as well. But I will appreciate that for sure if you can do that for me. Plutonium levels on the flux capacitor. We're going back in time here. Translate amazing goes to incredible. Surfer. Yeah, we should have a... That'd be really funny, actually. We have Pirate, which is kind of a fun one. I actually just installed Pirate language on one of my devices the other day. It would be pretty cool if we had... well, it'd be kind of fun if we had some other ones. Surfer. That'd be really funny. Wookiee. You could do stuff like Tolkien has a bunch of languages, right? Maybe you could do Elven or one of those languages that Tolkien made up. Or I know a lot of folks do, Klingon or something from Star Trek. It's lots of fun stuff there you could do. Home Assistant dashboard. Coffee time. Heck yes, for sure. Groot. Okay. The Groot translation will be easy. Yep. Or yeah, you like Pokemon or something, like Pikachu, and it just says Pikachu over and over again because they only talk with their name. Okay, so we need to grab the libraries for these sensors. So I have not ever used these sensors, I don't think, or I'm sure. I guess this one I'm sure I probably have since it was plugged into a stemma cable when I found it. But I don't remember using it, and I certainly have not used it on this device. So hardware-wise, I'm a big fan of stemma stuff and also featherwing doublers. I'm not using a featherwing doubler here. But I'm a big fan of those as well because they make it so you don't have to worry about wiring. So you got a stemma cable here. I don't know if I'm going to be able to get it to focus, but one thing is that the holes in this cable are closer to... you can kind of see it there if I get the light just right. The holes are closer to one side than the other, so it's not universal. There is a right way and a wrong way, and those pins that are inside there, those are super tiny pins. I have no idea what size they are, but they're super tiny. You definitely do not want to just jam this thing in there too hard. So you give it a nice little push. If it's not going, then maybe you got the wrong way. Take it out, flip it over, see if it's the other way. Or the other thing you can do is if you look in there, you can kind of see which way it goes. So looks like mine is this way. There it goes. But that's all we got to do for wiring. So I don't know. It's probably not going to like twisting it out like this. So we'll just look at the back of it there. SI7021. Let's get the library for that. CircuitPython SI. What was that? 7021. GitHub. So one thing, I could download it from GitHub. I also have the bundle downloaded already. So I think what I'll do is on GitHub here, I'll come grab the simple test. We'll set up the sensor that way. Let me save this off. Basic roto zoom code. And then let's go close, open CodePy, delete that, and then, you know what, let's not delete that. Instead, let's keep some of it, but delete some of it. Get rid of that. We're not going to use RotoZoom. One thing about the dial gauge, it does use Vectorio, or it's probably supposed to be Vector IO. It does use Vector IO underneath the hood. So, and we don't have a Blinka display IO port yet for Vector IO, to the best of my knowledge, which means that we can't use that dial gauge with Blinka display IO, which means we can't use it with like the Pygame display. If you've watched these streams before, you've probably seen me use the Pygame display a fair amount, and we won't be able to do that yet until we get Vectorio implemented in Blinka display IO. So if anyone is good with vector math and wants a challenge, this would be Python code inside Blinka display IO. If anyone is interested in trying to tackle that, that would be super amazing. I will probably give it a try one of these days, but I don't know very much about it, so it's definitely going to be an uphill battle for me. But I would love it if we had a Python implementation of vector IO so that we could use it in the Pygame display and Blinka display IO world. Okay, so we paired this back. I have just the Featherwing getting set up now. Setting up a display. One thing I'll do, I kind of like main group for the name of my main group here. We'll go display.group. Take out these comments here since that's for a different thing. Okay. Group. Let's say we want to have enough for, I don't know. We probably don't need that much, honestly, but I'll just do 10. I like to throw 10, that way just a couple of empty slots I can put something into if I need to. Speaking of which, actually, I'm on a new enough version of CircuitPython, maybe this doesn't even matter anymore, because in the core, group is no longer having this max size. So pretty soon we're not going to have to bother with this at all. Stick it with 10 though, and let me initialize the sensor here. I'm going to do it after the screen. I'm also going to do it, going to call display.show main group. And or .i2c, can we call that twice? I want to say we need to store that in a variable, because this is like an initializer. I think it's going to call this function again if we go to set up the second sensor. We'll see though once we get to there. I'm going to call this one temp sensor. And I'm going to need to copy the library, so I do already have a copy of the bundle. You could use circup if you wanted. That's what I use sometimes. For now, though, I'm just going to copy this one. SI, there it is, 721. CircuitPylib. You know what? While I'm here, why don't I just go ahead and grab the library for the other one too, BH1750. Guessing that's going to be here. Yep, right there. Might as well just grab that one at the same time. Okay. So that's our sensor, and then it's probably just sensor.temp or something, right? Sensor.temperature, yeah. So we can do that pretty easily. Maybe we'll just print them once and then do nothing else for now. Let's just make sure it's working. Okay, sensor is not defined because I changed it to temp sensor. Okay, perfect. Yeah, so the display went blank, which makes sense because I initialized the display context. I created a group and then I showed my group on it, but there's nothing in my group, so that's why the screen went blank. If I had not called display.show right here, then we would get the REPL output right here, this thing where it's just Blinka in the corner and the text, and it would show our print statements. It's not wanting to focus. Maybe we can get it there like that, but you can see them there. So if you don't call display.show, if you don't give it a group, then it will just stay in the default here, which is like the terminal IO printout of whatever gets printed. We're going to be drawing a dial gauge, which we're going to have to put in a group though, so I'm going to go ahead and do that. Let me catch up on the chat here. Added 600 boards. Wait, what? Yeah, thank you, Hugo, for linking that pull request. I appreciate that. Is the feather... I do think it's sold out, probably. And yeah, to Hugo's point, probably again. I know they put... When they first put them in, they put in like only a few, like 20 or 40 or something like that. Those went pretty quick. They got another batch in there. Okay, 600 boards. They added 600 feathers into stock. I see. Oh, and they are in stock right now, so you can buy 2 of them if you want them. Let me see, back to the chat here. Still available too, yep. Yeah, tattoos are definitely going in my next order. Yeah, for sure. K-Match, thank you for all your work on the docs. Yeah, I'm happy to show people that it's a bunch of really nice work in there. So, yeah, I think it would be good to do a stream on Sphinx specifically. Maybe one of these days we'll focus on just that. The clue. Yeah, the clue has a screen. Circuit Playground, if you're going to go Circuit Playground with a gizmo, I'd probably recommend Bluefruit, Circuit Playground Bluefruit, instead of Express. Express is an M0. It can use the gizmo, but the M0 devices it's tough on display I/O. There's really not enough memory to do a whole lot. Like if you want to draw more than 1 or 2 things, or you want to do very much at all other than draw 1 or 2 things, then you're probably going to run out of memory, unless if you really like the challenge of squeezing every last bit of efficiency you can out of stuff, and then you can kind of get some stuff done. But if you want it to be easy, I would recommend on the gizmo side go with the Bluefruit. Other devices to look at, the PyPortal is really nice. It's got a built-in screen. Johnny linked the PyPortal Titano there, so that's a bigger version of the PyPortal. That one's really nice. Other stuff with built-in screens, this one right here, PyGamer. This is really nice. It's in a case right there, so it looks different if you have just the bare board. But that one's got a nice built-in screen. It's got a D-pad type thing and an A and B button, so if you want to play games and stuff like that, that's a good choice. The Clue is a great choice. It has a screen on it. It's got some sensors and stuff built in. More tattoos. E-Ink Featherwing. Yeah. Feather M0. Yeah, it's tough, man. Those displays. Anything with display I/O. There's like, I want to say there's like 2 devices that are M0s that have that have the ability to do display I/O at all, and it's like the Halloween M0 and the Gizmo, the Circuit Playground Express with the Gizmo, and it needs like a custom special firmware for it to do it, and it's tough. Those are the only 2 really that can do any kind of displaying at all, and they really can't do all that much. Oh no, Johnny's PyPortal. Johnny's poor PyPortal, that's terrible. Okay, we got our printout. Let's make a dial gauge. So for that, I will just grab the example code from the repo. Dial simple test right here. Let's grab this to start with. We will probably need a couple more of those variables. Let's start with this though. XY position 2020, that makes sense. Width and height, I'm gonna make 2 dials. So why don't we go a little smaller? My screen is 320 by 240. So 15, 16, 160 would be half. Why don't I go down to let's do 120. Yeah, let's do 120. See where that gets us. I'll leave those the same. Maximum and minimum, I will do... let's do humidity. Yeah, let's do humidity because I think I can change... the humidity easier than I can the temperature. And humidity is a percentage, which is nice. We know that percentages go 0 to 100. So we can just hard code those there, 0 to 100. Font, I think we can, let's use default font for now, terminal io dot font. Scale 2, we can leave that. And then let's add this to our group. Dial. Save that, see if it draws. Dial is not defined because this is called my dial, but I'm just going to actually fix it right here and say this is the humidity dial. Humidity dial. See if we can focus again, maybe. Oh, I need to import dial, of course. Here we can grab that. I don't know, I might need to update. Yeah, I was gonna say, I might need to update display layout because the one that's on my device is older. This just got merged in the other day, so the one that's on my device is a little older, doesn't have this yet. Did we make a release? Display IO layout, widget style. Okay, that one's there. Let's copy that. Delete that one. Paste it. Okay. Oh man, we did get this error again. This is the first time I've gotten it since I added the sleep. I think it's because of the way it was restarting while it was pasting all those different files. Pretty sure if I just go back and rerun this, it works the next time. It's something to do with time. I'm wondering if, oh no. I've gotten it stuck. Or maybe does my version that's on my device not have the sleep in it? Man, this is a bummer. I really thought this was behind us. So this opened up here. This does have the sleep. And it says 67. So it failed the first time and it failed again the second time. And like right now it's like stuck. It's like never gonna find it. But if I reset, then I bet it's okay. Okay, let's try that. Here, reset. Okay. So we do not have terminal IO imported. So we got past that issue. So, you know, again, this thing, whatever is going on with it, like, gets into that state, and then it doesn't want to import. It seemed to be time-based. Like, up until just now, I had not seen it again ever since we put that time.sleep in. And it seemed like this time it got, like, stuck, where not even having the sleep was helping. And I really think it was to do with the way that my computer was, when I was copying those files, it was causing it to restart the device over and over again. I gotta think that was probably the issue. Okay, we got a nice looking gauge now. Let's close a couple more of these and get the size looking good. Let's make it a little bigger. We can go, let's try 140. The other thing is the padding has to do with this as well. That was pretty good. Yeah, let's leave it like that. Let me catch up on the chat. Latest out of box, yep, temporary tattoos. Permanent one. Sphinx, yeah, I totally agree. Sphinx's syntax is kind of crazy sometimes. Doesn't make sense what it's asking for, and I will say the errors are not so great either. Like, it gives you an error and it's like unexpected line or something like that, and really the problem is like the quotes are in the wrong spot or something. Like, it's not good at telling you what the error is. Okay, talking about Sphinx some more. Yeah, I would love to see. I'll have to dive into that one of these days. Maybe I'll do it on my stream. Okay, we got a gauge. Let's set the gauge to the value from the sensor. So sensor.relative humidity. We can go humidity dial dot temp sensor dot value equals temp sensor dot relative humidity. And we can also make sure we have time, which we do. We could also set this in here to update it, and then maybe we'll just do a something like this, slow it down a little bit. So that should keep it updated, the dial gauge, based on the humidity from the sensor. So it should go to like 20 something. Let's get it focused here. There it is, and that's working. So it printed, well, I didn't have my serial open, so we don't get to see what it printed. Maybe if we used, oh, what was the name of that? It was display value? Yeah. Maybe if we set that to true? I saw the humidity there was 27. Yeah, there we go. So we got a 27 in the middle. That's looking nice. Okay. Let me actually switch this over to the longer stemma cable. Got two stemma cables here. One of them is super duper short and one of them is a little bit longer. So I'm just going to unplug that for now. I will unplug this. and this. There we go. And I'll use this bigger one. I really like these feathers that have the stemma thing on the end. It's a relatively newer thing. Not very many of them have that yet. IMX, no, STM, the STM 3405, that one does. Unexpected Makers, Feather S2, that one does. I don't know, Feather Sense maybe? I'm not sure if that one does or not, but like Feather M4 doesn't have it. Okay, there we go. So our relative humidity went up a little bit. I think maybe I had my finger on it, like right when it scanned or something. So possibly that's the reason why. Let's see if we can focus here. 32. And so now theoretically, if I can get this thing over here. Well, it's a bit of a balancing act to see if I can get everything at once. That text is a little small, but you got a 38 in there, and if I come in and breathe on this a little bit, you can see that it's chunking up there. So all the way up into the 40s, almost 50% there, 52%. So you can see there our dial gauge is reacting to the humidity. So that's awesome. That's exactly what we want. Sorry, I just bonked the table there. So yeah, let's make one for the light sensor also, and we can just add a second dial to this. So we'll make a little cluster gauge looking thing here. I'll start with all the same stuff. This one I'm going to call the light dial. Timing errors are terrible, yeah. Yeah, the touchscreen timing thing is weird. It's complaining about not finding a specific version. Well, I think though it's complaining about not finding the chip altogether. It prints the version because that's the one that it knows it's looking for, but I believe it's not seeing the chip altogether. Although version, maybe that's a good theory. Maybe it's getting jumbled. Maybe it's like getting message back from the sensor, but the message got jumbled and therefore the version doesn't match what it's supposed to. That could be. All right, let's go light dial. Let's play with this one a little bit. That red one looks really nice as a default, but let's really kick the tires a little bit more here and see what we can do. Let's go a different needle color maybe. Needle color, and this can be hex, so let's go, why don't we make this one yellow, so like that, and let's go a little bit thicker. I don't know what the default is. Let's just try something like 8 and see where that gets us. We do need a different X. Let's say we want another 140 pixels over, so that's 160, but we also want 20 pixels between, so 180, I think. Let's add this to the main group. Okay, and it will default to 0. Yeah, let's try that. See how well I can get the focus to go. I'm not sure. The light makes it tough. Here we go. Okay. The size looks pretty close. Let's chunk that up a little more. Maybe let's try 18 and see where that gets us. And then let's also do the value color. which is value label color. No, value color. We'll do yellow also. There we go. Okay. Maybe that's a little bit too thick. Let's try it down on 10. It's probably fine to keep the default, but I'm interested to tinker around with this and just see what all it does. There we go. Yeah, that's looking pretty nice. Okay, so the next thing is that the light sensor we have does not give us, I don't think, a value from 0 to 100. Instead, it gives us 0 to, well, it says on the back, 0 to max int, basically, 65,535. That's not max int. Well, maybe in some languages. Do we want to map it back, or do we want to set our minimum and maximum to those? Let's pull up the library for this one, and let's take a look at what the API is. One thing is this could be updated to not use bus.io. .lux. Simple test. Does it have anything besides lux? Ooh, what is CV? Should have a better name for that, maybe. CV value. Color value? I don't know what CV stands for. RW bit fields. Where is our? This is our main class here. Lux. Yeah, just lux. Okay. That's the only public API accessor we have there is lux. So that's what we'll do. It is gonna give us, I'm guessing, this range it says on the back, which again was 0 to 65,000. I don't know if I'll be able to focus it again. Just got lightning in a bottle last time, but why don't we... Let's see. I don't know. I don't think we want to do it this way because then it's going to try to make labels that match these, which is not, I don't think, what we want. But let's just see what it does. Okay. It didn't change the labels, so maybe that's fine, actually. Because then the numbers will show a percentage, but the actual value can be a 0 to 65,000 type deal. Okay, so let's give that a try. So let me grab the code back from here. We want to initialize the sensor, which we need to import it, and I am gonna use board.i2c, but I'm gonna save it into this variable. Light sensor. And now let's go light dial.value is light sensor.lux, and then we can just add the same thing into here so that it updates. And then the other thing that we need to do is actually plug it in. So right now I have just the temperature sensor. So I'm going to take my other stemma cable here. Nice thing about stemma, you can chain them, so there's a plug on both sides. So I'm going to plug my little one in here. Let me get that out of the way. Plug my little one in there, and then we'll plug this one onto the end of that. There we go. So now I've got them both chained on there. And let's see, we do want to try to get it here where the light sensor's pointing upwards if we can. Can give it a try like that. We don't want to pinch our wire too much, but we do want the light sensor to be looking up because that's where the light is. And if it's not facing the light, it'll be 0, and we want to see it go up some on the dial. So let's do that. We didn't save this, so let's do that. Let's give the needle some mass so it bounces. Ooh, that would be fun. Yeah, I know K-Match is working on tons of animations for stuff, so maybe there's opportunity there for animations in this library. Okay, so we got 300. That's not too much. If we point it like right back at the light, we can get a little higher, 470, but we're still well under 65,000. Maybe I can add some with my phone light here. So, well, that covers that up. Let's try it this way. Yeah, that gets us a little higher, 1300. And you can see the dial gauge is moving a little bit there, but boy, you would need a lot of light to get to 65,000. If I point it at the window, no, that's even worse. Let me try this. I'm gonna go open these blinds that are by my desk here and let some like all natural sunlight in. See if that see what that does to it. Yeah, that got us up there, 421. So that added a little bit of ambient light to the room. One thing we could do is cover it. Like if I cover it like this, it goes way down, all the way to 2 or 3. So we know that's working. I kind of want to see it make a bigger impact. So I think what I will do is get some extra light there, and if I go like, oh, let me move some of that stuff. Okay, if I go like right on it, my phone has a light here, so that's what I'm shining right onto it. There you can see I got it up pretty far. That's like 20,000 right there, so that's almost halfway, but that's like with the light from my phone directly in it. And if I come up even a little bit there, you can see we drop off by about 1/3 or so. So we can see it's reacting live there. I think one thing I'm going to do though is just remap it a little bit. So instead of doing my maximum at the actual maximum, I'm going to just cut that in half, because we only made it up to about halfway when we put the light like right up in it. So maybe we can do it here and it will scale a little bit higher for us. Okay, so value is the same, but the actual amount that the needle moves should be a little more now. You know, we still kind of have a fair amount of room we could go, truthfully. What if we tried a factor of 10 instead of a factor of 2? The other thing is, I don't know if value, if we set it to, well, we can test that actually. Why don't we just test that? If you go light dial dot value equals bigger than the max value, does it crash? No. It's fine. Okay, so it probably, I guess, probably just ignores it. I'm not 100% sure. We would have reset it right here, so we didn't even really get a chance to see what it did, but it doesn't crash, and that's the important part. So we can go divided by 10 here, and that will make our needle move, should make our needle move quite a bit more for each unit of light, whatever a lux unit is. I'm not actually sure. There we go. Yeah, now we're up on the first tick mark there with 390. If I point it kind of towards the window, we can get up to 400 or so. We can see it creep in there, and then if I point the phone light on it extra, we can creep it up to 900 and even higher if we want to get it right up on it there. So one thing we can see there, what happened is that it did wrap. It wrapped back around on the bottom side there for when it went outside the range. So here you go. This is a pretty good multiplier though, because I can kind of move my phone back and forth a little bit here, and we can see that needle really jump basically the entire gauge now. So pretty cool stuff. How's it going, David G? Thanks for joining us. Let me check up on the chat here. And we just hit our 3rd hour, so I'll probably be wrapping it up fairly soon. But let me just take a quick look here. Check out switch round. Yeah, there's the animations on that round switch turned out super nice looking. That really looks like a mobile interface on a modern phone. The way that thing is bouncing around there, that's really sweet looking. When I point out error message problems, oh yeah. Somebody said make a PR if you want for the mass bouncing. I think they mean there. Yep. Get out of the cave. Yeah, it's pretty dark here. This sensor though, man, it says maximum 65,000, but like you would have to just point a laser pointer or something at it, I think, to even get near that. Like, I flashed my flashlight right on top of it, and I still only got to like 30,000 or something. Pick another range. Yep, that's what I ended up doing. Yeah, okay, so we're caught up there. So yeah, this is cool. We managed to make a little heads-up display here. It's got a light sensor, and it's got a humidity sensor. We could add one for the temperature if we wanted to do temperature as well. Our temperature sensor is giving us a value for that too. Right now I've just done the humidity, but we could grab temperature if we want. You know, one thing that would really spruce this up a bit is if these dial gauges had a label on them, maybe down below them, potentially. Yeah, why don't we add a couple labels down there? And then I'll probably wrap up after that. So let's go, I'll make probably a bitmap label. So from, it's probably not in there, adafruit display text, import bitmap label. And then I'm just going to go copy the initialization. I'm a big copy paster. So we'll go here. Gonna make two of these. So this one is temp. Well, It's actually humidity label. And we'll do Terminalio fonts fine. Okay. So I'm going to try to put this centered below the gauge. So anchor point is 0.5, the midway point for X, and then the top for Y. Anchored position that will be X is the midway point of the first dial, which is 70 pixels in, but with 20 pixels for the X location. So I think it would be 90. Truthfully, the right way to do this would be something like call up this width over 2 plus the dial again dot X. And then the Y position, we want it below. We want it below that, which would be 140 would be the bottom, but we also have our 20 pixels, so 160. Maybe we wanted a few pixels past that, so could go, this will be the height. We don't want to divide. We do want to add the Y, and we also want to add maybe like 10 more pixels, let's say. And yeah, let's see where that gets us. Let's see. Maybe try a dial with sweep angle 0. Look forward to playing with those. We got a mag tag. It's hard. Yeah, you can't do the animations on the e-ink for sure. Those labels with the angle are computed. Yeah, that's correct, David. It's not a bit. I mean, it does get stored into a bitmap object, I guess, to draw onto the screen, but it's not like a BMP image file. It's a label that has been rotated. Yeah, and vertical is coming as well. I played with that got merged in last week, so or maybe that was earlier this week. I don't remember. But the label class Jose's mentioning here. Jose made an enhancement to label to where it can go a bunch of different orientations. It can go backwards, it can go downwards, upwards, all kinds of different stuff. And so there's another new PR there on display text to implement all that same stuff in the bitmap label, which is awesome. Yes, roto zoom, yeah. Okay, so we're caught up there. This does have a problem. None type is not callable. Yeah, this is not a function, but it should be a setter here. And it is a tuple though. Nope. 82. Oh, yeah, this one also is not supposed to be a function. There we go. Also, we need to add the label to the group, otherwise it's not going to show. There we go. And it is centered below the dial. So I did get it to basically the exact right spot that I was trying to aim for. So that's nice. It's kind of small. It might be nice if we could scale it. The only problem though, I'm not sure if we will. Scale 2 might be too big, which is where the real solution is that roto zoom that we messed with earlier, because that would allow us to do like scale 1.5 if we wanted to. For now though, I'll stick with integers. The scaling that's on group is integer, not float, so we do have to use an integer this way. Let's see how that looks. That looks pretty fine though. I think we'll still have room for the light one over there, so that's good. Humidity, let me add one more for light, and then we'll probably wrap this stream up for now. Light label. And we'll go on the light dial. Here. And the text will say light or lux, maybe? And let's go light. And best of both worlds. Why don't we go light / lux? If we wanted to be super proper, we could also maybe put % here so that you know the units. Same thing as last time. I didn't add it. Well, okay, actually I did add it, but I added another copy of humidity, which is not what we want. Jose linked probably, I'm gonna guess, rotated bitmap. Let me see. Bitmap label, that is. Yeah, directional bitmap label. So I'll be checking this one out pretty soon as well. One thing I want to do as well for these directional labels, I think we want to make a simple test for those. These tests that are in the PR are pretty good. These are comprehensive. They show all the different angles and they have these lines which make it easier. I think we should make one in the examples folder though that has maybe just one label of each type, and we don't necessarily need the lines. I think the lines might maybe confuse people. They're really good when we're testing to make sure stuff is lining up. For the example though, I think if we just make one with one of each type of label in each orientation, and then no lines, and then I think that'll be perfect to show folks how to use it. So, and again though, this is merged in already for regular labels, so you can already start using this stuff with label if you want. And now the PR is open here for bitmap label. So if anyone is interested in this sort of stuff and you want to help us out with reviews, definitely come check out this PR and try it out on your device if you can, and leave a note there what you find, if it works out for you, or if you notice anything weird that you would rather change, that kind of stuff. We're always looking for more reviewers. So anyone who's watching this, if you're down to review, please get involved that way. And if you have any questions about, like, if you don't know how to do something, or if you just need help learning, what to do when you review, definitely reach out to us on the Discord. We're always willing to help folks come up to speed for reviewing. Do this widget has a color theme? The color theme by default, I guess it would be the white ticks and the red needle probably. Yeah, hooks. I think if we add, my vision for it is on our widgets, we add like a set theme, and then the theme takes a dictionary object, and the dictionary object has, background color, foreground color, font size, whatever else we decide goes into the theme. See you, Hugo. Thanks for tuning in. that would be my thought, though. We create a set theme, and the set theme just expects an object that is a theme with all that stuff in it. Where were we at here, though? We tried to make the light label, and it seems stuck. Let's give it the old restart treatment here and see what that does for it. Oh no, we're back to the chip thing. Boy, I really wish I knew what caused this and if there was a way to like reset it harder, basically. I mean, I guess I could call os.reset or something. That's tough though. Like I'm weary of that, because if it keeps failing over and over, then we're going to be in a boot loop. Boy, I wish I knew why it was doing this, or more specifically, a way to make it stop. I think there's like something is not getting released from the touchscreen, and there must be a way. There must be a way that we could like forcefully like catch this error and then like clear everything out about the touchscreen and try again, but I don't know what's doing it. So for now, I'm just gonna give it another reset with the button, and I think it's gonna go right back to working again. So let's give this a try. I really think it has to do with when it resets. Like you can see there that it reset twice because my computer connected to it and tried to write something, I guess. I really think our trouble is coming from when it tries to reset while it's already in the process of doing it from last time. And so it gets like halfway started up, and then all of a sudden it gets another command to start up again, and it's like, hey, we're already partway through that. So there's our light sensor. The needle's moving there. You can see as I turn that towards the light, it does say light and lux now, so that's looking good. Yeah, so this is a nice little example that shows how to use the new dial gauge with dynamic data that's coming out of sensors. So this is the kind of stuff we can do now with these awesome widgets. Alrighty. Nice. Best way to integrate with all, yeah. Yeah, one thing we'll still need to do is the run cookie cutter to make a new themes library. That one color sys, that's going to end up just being helper functions with color sys, and it's just going to match the CPython color sys. But what we'll do is we'll make a new like Adafruit CircuitPython themes, probably will be the name, or Adafruit CircuitPython styles, one of the two, and that one can hold all those themes for us. Yeah. Luckily, I will say one thing we have going for us, like we're picking up speed right now, but we're still at the very beginning of all these new widgets. We still only have a few widgets. So like right now is definitely the perfect time to go and add themes and any other functionality that's like gonna require changes in the widget. Like, now is the time to do it, because we're only gonna get more and more and more widgets as time goes on. So anything that requires a change across all of them, if we can get those in up front and just start building them with that in mind, then we'll alleviate some of that work in the long run. Yeah, TG Techie is working on a watch. Shout out there as well. TG Techie has, I think, is it called TG GUI or Techie GUI, something like that. TG Techie made a whole framework, a whole GUI framework with an event system, and everything is all built in for that watch that they're working on. So that's really cool. And they did, what else did TG Techie made? They made a slider, which was really cool, like a finger slider widget. Like you can drag it back and forth, and it's basically like a volume input type thing. You can have it all the way down to the bottom or all the way up to the top or somewhere in between. That widget that TG Techie made that slider was really cool. He did a stream one weekend, a couple weeks back, that showed how to use that thing. Nice looking Dexter, nice looking gauge there you got on the screen. Needle size. Ooh, can you have 2 needles? I don't think right now you can have 2 needles, but maybe you could cheat by making a second. Maybe you could layer on a second gauge that has no tick marks on the upper gauge. 360 I was thinking of as well. If we could do 360 degrees, one thing I wanted to do was, I think this would be good for a compass, because we have magnetometers, magnometers, I don't know if that's the right name. We have sensors that sense magnets, and the Earth is a giant magnet, and if you do the right kind of math on your magnet sensor, you can know what cardinal direction your sensor is facing, or something like that. And this dial gauge would make a perfect, like, north, east, south, west, 4 points there of a compass, and then we could read the magnet data and point the needle at whichever one of those directions. I was thinking that would be a really cool use of it as well. It's kind of outside the box a little bit of the sort of 0 to 100 progress that this thing is kind of, defaulted to do, because it's like a degrees. It goes all the way around, but something like that might be really fun as well. Possibilities are endless. All right, so I think we're going to wrap it up here. Thank you, everybody, for coming. David, K-Match, Dexter, Hugo left a little bit ago, but thank you to Hugo as well. Jose, Johnny. I think maybe I got everybody. If I missed anybody there, I'm very sorry. Luz was here. Luz there and Telemon showed up for a minute there. Thank you. Everybody who tuned in, thank you so much. I really appreciate you guys coming and hanging out. This is one of my favorite things to do in the week now is this stream. So I look forward to it all week. It's really fun. So thank you for tuning out. Thank you for hanging out in the chat. Thank you for tuning in on YouTube or Twitch, wherever you're watching. I will be back next week. Yeah, it should be normal time next week. Let me know. One thing I've been thinking about is when Scott's off on Fridays, because I think he mentioned yesterday that he's going skiing next week. So next week's deep dive is Thursday. When Scott's gone on Fridays, are you guys interested, or do you think folks would be interested if I streamed that night? Like, I could do Friday evening. One thing I will say though is I can't start at the same time. He starts at, it's 4:00 p.m. my time. I think it's 3 or 2 in his time, Pacific. I'm not sure, but it's 4 p.m. my time. I would have to wait until 5 p.m. my time. But I could probably start at 5 p.m. and go for like an hour or something like that. So let me know in the chat if that's something that you think would be interesting on weeks where Scott takes Friday off. If you guys would still be interested in having, similar type of content on Friday evenings, let me know. I might do that. I don't know if I'll be able to do it every week, but maybe we'll try that out. Maybe we'll try that out next week. I feel like there's lots of folks hanging around, ready to consume something like that at that time. And if he's not going to be there on Friday, then maybe I can step in and we can still have some fun hangout time on Friday evening. Because that's another thing I look forward to is hanging out, watching Scott stream. So when he does Thursday, then Friday evenings I'm like twiddling my thumbs, like what am I going to do? So maybe we'll try that out. We'll see. I don't know for sure, but keep an eye out on Friday evening, and if if I'm feeling it this week, if I don't have too much going on for work or anything like that, then we'll try that out and we'll see how it goes. But for now, that's going to be it. Again, thank you everyone for tuning in, and we'll definitely be back on Saturday next week for sure. So come back then, Saturday 10 a.m., and then we'll definitely be here at that time. So thanks everybody. Until next time, I will talk to you later. Oh, we got our camel there. That's nice.